evidence sort of situation. So, by popular demand, today, we're just going to do this. Because I'm assuming this was a ton of fun for everybody, right? So, yeah. I'm going to do it weird. I don't know. I just feel like starting with the Juniper one first. I have no particular, reason why, other than I just feel like it. Or that's what I've been tinkering with most or helping folks with is the NAT. So if nothing else, by the end of this exercise, when I initially started NAT and I told you it's all awful and terrible and NAT's just a bad thing, I think you all understand why now, right? Because it is just kind of a bad deal. So first thing I'll actually do is there was my fix that we had to do. So if we looked at routing options, I have a typo. And this next top 24.221.181.182 goes to nowhere. So we needed to delete routing option static and then set routing option static route 64.0.0.0/8. There we go. 102 like so. That was the fix to make things happy. Anyway, for actually doing the lab, what's aside from fixing this part, what's the actual first step that we needed to do? We need to set the interfaces. So we had the very first interface, gigeth0. What do we need to do? And what IP address should we use? 2.1, yeah. So there. INET address. Oh, I hate when this does this to me. There we go. We got that one. Then we can come in here and say gigeth1. Where does that need to go to? I genuinely don't remember. Oh, there we go. 253. And finally, there we go. Is there anything else you needed to do through command line for this? No. Just commit it. And life should be good. That should be all we need to do inside of here. And there we go. So let's open up goat admin. So there was really, in the end, I suppose 3 firewall rules we needed to make in here, right? 3 firewall rules and 3-ish NAT rules. So we had to allow, there we go. Allow the internet to access server 1 on port 80, but block the dog network. We had to NAT port 8080 over to the other web server, and really that was the primary thing. Like we said before, this showing unnecessary rules and whatnot, it's really easy to make this lab work if you just go add allow any out there. That's the point of this, is not having rules that are unnecessary. That would be an unnecessary rule to make. So that's the point of that. So if we go in here, regardless of firewall rules though, what do we need to configure first? We got interfaces done. We got to start with zones. Yep. So we have to set up the zones. Log in here. This is not a real firewall. There we go. Can't begin to tell you how many times I've typed real passwords into things when I'm doing labs and people's homework or helping them. Because you just kind of get the muscle memory of like the little Juniper logo comes up and just type stuff. Nope. So first thing we need to do is set up the zones. What's the point of the zones?
It's a way of firewalling logical groups as opposed to interfaces.
Yeah, we can start to group things together with logical groups. The big purpose behind that is it's one thing to have interfaces. In our case, like this firewall has, what is it? I have up to like 6 active interfaces, I think. You could add more. The IA Labs firewall has 10. So it's not like it's an overabundance. But what do we do that would make an overabundance of actual layer 3 interfaces?
VLANs.
Yeah, we could VLAN stuff. So then all of a sudden we go from 10 to like we could have 1,000. So rather than managing all those individually, we have zones. So if we remember, this trust zone is used by default by what? By what?
Sorry, it's WAN.
The trust one?
Yeah. Right.
No. What's tagged inside of this trust zone by default?
You.
What's in there? Under interfaces, what do we see in the highlighted line?
No.
Nothing, yeah. That zone's not used by anything by default. Yeah. Yeah, what is it used by? Nothing is in there. What this does, my assumption, is that the idea behind this is you plug in your local network, you run the little wizard when you get this little firewall, and it will recreate the zone, or not necessarily recreate, but it will set up an admin-y type of interface zone for you, where you could access like the firewall's interface, and then it would place all of the users in an untrust zone and put a different interface for admin. So that's what we would move over into trust. But for now, like we said in class, it's silly that it's putting the admin interface in the untrust because that's maybe not how we would do it, but it is what it is. I didn't pick. It's what it does.
So if you remove that interface from untrust,
I wouldn't do that.
why does it break things?
So the reason why, if you remove this from untrust, because logically, and you can go in, you have to, you'd probably have to do this through the CLI, but you could move our actual admin page over into the untrust zone. The reason why, when you remove gigeth0 from untrust, if we go over and look at the services that are running on gigeth0, we see HTTP, HTTPS, SSH, and Telnet. Those are maybe not so much Telnet, but the other three. When we have a firewall running the HTTP service, what service is that we're actually accessing? That's the actual web interface, yeah. So that's how it's defining like this particular interface is allowed to have this particular like physical plug-it-in interface is allowed to display the web page, or you can SSH into it or something like that. So
When he did his zero eyes, because we were talking about it, when he did that, we did the show system services, to make sure that it was active, and it was still it was still labeling gig Ethernet 0 as accessible. But if I remember correctly, it still bricked the web interface.
Yeah,
So
and
that
so
is
I removed
that
it.
config is under zones always. So if you go into security zones, that's where you see the services are. If you go and look in the actual system services, that is specifying rather the actual web interface itself as even the service is turned on. Then what this is specifying is where is that service accessible from.
Okay.
Does that make sense?
Yeah.
So that's why. In the end, we would maybe say moving things around or changing the admin interface location. We call that that's a next level achievement to get, right? When you level up with your firewall, then we can start to move around. But like if we go into the IA Lab one, I'm pretty sure I removed it from. I think I've actually completely deleted the default zones altogether. I have an admin zone, and then like student zone and stuff like that. But that was me banging away at the keyboard and didn't even really realize these were the defaults until I started playing with this VM because I never really looked at the defaults for it, which probably was my bad. Anywho, what do we need to do here?
Add LAN and WAN.
Yeah, we need to add a
Or DMZ.
DMZ sort of interface, which was gig 1, or I believe.
Yep.
And we need to add the WAN. Actually, now that I think about it, inside of the IA Labs firewall, I think my untrust zone is still there. It's not used by anything. I have an internet zone. So that's how I got away with that. All right, we got our zones. What's our next step? Because so far all the stuff that what we've done is not really even described that we need to do in here, right? So now we need to go through and do these bits. So what does Juniper evaluate first, firewall or NAT? NAT. Everything is done by NAT first. The packet goes from the interface and hands over for NAT processing. So we need to make sure we get that right first. So for the very first rule in here, allow anyone on the internet to access server 1. What type of NAT is that? That's destination NAT. Because we can think about that. If we have the internet coming in, do we know the source of the traffic? If it's the internet.
Oh, no.
No, we don't know the source of the traffic if it's the internet. If we have the internet coming into one of our servers, do we know where the traffic is going to? Yeah. We know it's going to this particular IP or this particular server. So we add a rule set, which is a complicated way of just saying a folder, essentially. So we'll go DNAT, internet. We can do this by zone, preferably. Oh, I called it WAN. See, now I'm already getting my... And then some of you did cheeky things like call your zones animals and stuff like that. So I'd log in and be like, what in the world? The cat zone and the dog zone, and there's a ferret zone, and it was like, that's going to take me a minute to figure out. So shout out to that person that you made me think for a second. So either way, you can hit OK, or we can just add the rules in here. It doesn't really matter. So for this very first one, we had DNAT server 1 on port 80, right? I think that was our objective. Yep. So we go NAT the internet to server 1 on port 80. So when we're looking at this, do we know the source of the traffic? No, we don't know the source because it's coming from the internet. So you can, I think, technically leave it blank or enter the wildcard subnet in there. What's the destination going to be?
192. Oh, sorry.
Yeah, you're a step ahead. So 24.220.181.10 what? Where do we get this address from? Yeah. That is the IP address that's on our WAN interface. This is our outside facing one. And that was 101/32. The really, really common helper head for folks is they had the other firewall's IP address in there. I accidentally had the Palo Alto's firewall in there. So that wouldn't work. So we do it on port 80. We need to create a new pool for it. What is the pool? Juniper's using that term to add a new NAT pool. What are we really providing in here? Yeah. So this is like matching where the traffic's going to on the internet side. When we add a NAT pool, we're saying, where does the traffic go on the other side of NAT? So we add the pool. The server 1 HTTP. And that was 192.168.253. 222. On what port? 80. We'll hit OK on that. We'll pick our new pool. And away we go. So we'll hit OK. And we'll commit this. Now at this point, is there any testing we could actually do?
No.
There is actually one small test we can do. Because even though, will this work right now? Will anyone be able to get to it?
Firewall should block it.
Yeah, the firewall is going to block it. But what is going to currently work, or we can validate, like if our logic is going right, is let's see if the NAT is actually applying. Because NAT happens first, so you can test if that works before you even worry about the firewall stuff. And then the other trick is, if this isn't working, you can make all the firewall rules in the world. Is it going to matter if your NAT's set up improperly? No. So what machine would be ideal to test this with right now? Why internet? Why the internet machine?
Firewalls to deal with and no natting.
There we go. So the internet is it behind any firewall? No. The internet is just a machine sitting directly connected to the internet. We don't have to worry about an outbound firewall with this machine. So we'll log in here. That's also a pro tip for future reference. If you're playing with firewall rules at work or at home or whatever, check it from your phone. Maybe you have some weird outbound firewall rule at home that's giving you grief. Turn the Wi-Fi off on your phone and see if you can get to the website or something like that. DSU, our IT department, actually has a Midco line and a couple of MiFis and stuff like that. We frequently use them to be like, is this something weird with our firewall letting us go out? Or is that website just dead? It's like a thing, right? So I try to go to it. No, it's not going to work. Now, could you have tested it from the get-go from the dog network? You could have, but you would have had to make sure to make all the outbound rules for it to even work in the first place. So if we refresh this, there we go. We got translation hits. So we see the session, if we look at successful, failed, and current, it failed. Why did the session itself fail?
Firewall.
Because of firewall. So NAT is sitting there tracking all the three-way handshake goodness going on. Did it ever succeed? No, because firewall blocked it. But the NAT rule translated the packet. That's what we're worried about for right now. So what do we want to do? Do we want to go make the firewall rule, or should we finish the other NAT rule? Do the other NAT? Okay. Doesn't actually matter. I'm just whatever order sounds logical. So we'll grab our rule set. We'll add another rule. And we're going to go dnat server 2 8080. Allow, we do this a couple ways. We can do allow dog network to access 8080 to 80. This can go either way. So when we look at the source, what source do we want to use in our NAT rule?
Put the WAN interface of the dog.
So
Fire.
yes, we could, not the WAN interface itself, because the dog network is routed or natted.
It's routed.
It's routed. So if we wanted to test this, or to do it specifically in just NAT for the dog network, we would put that in there. Will this let us test it from the internet machine? No. So my pro tip is to test this initially. Set it up like that. Now in the end, do we need to use NAT to restrict the internet from accessing this? No. What could we use? We could use a firewall rule. Does it make a difference? If you want, I always have an opinion on things. So my opinion on this is that use NAT to do your natting. Use a firewall to do your block lists. That being said, can you use NAT to do some block listing or blacklisting, whitelisting? Yeah, you totally can. It's an either or. If we did it this way, we now need to make a rule saying only allow dog to this IP. If we did it the other way, we could go into our firewall rules and make a firewall rule that says allow all to this particular port. In the end, that's why I would do my firewalling in the firewalling section. Natting, I would just NAT the port. Is that going to be true 100% of the time? No. But no matter what, do it consistently, I guess, is my overall advice. So either just do your natting with NAT and do your firewalling restriction stuff with the policies.
Could you theoretically use static NAT to accomplish this goal?
Not since we're sharing the IP twice.
What do you mean by that, sharing the IP twice?
So this IP address, the 24.220.181.101, is being natted to two different internal IP addresses, and that's where static NAT would probably let us down.
What if we're going on two different ports? Should it be...
Generally, that's where destination NAT versus static NAT are going to be different, because destination NAT is more port specific, whereas static NAT is usually just IP specific. That being said, I do think Juniper might actually let you do static NAT at the port level, which is silly to do because you're really doing destination NAT anyway at that point.
What's the difference? I can't really tell the difference between destination NAT and port forwarding.
There really isn't one.
Okay.
When you click on a firewall that you might have somewhere else, you click the port forward button. Oftentimes what that's doing is destination NAT and a firewall rule at the same time. Maybe not necessarily, but oftentimes that's what that's doing. Especially if you go into a Linksys router or something like that, it used to be called port forwarding. Now the tab is applications and games or something like that, I think. But it used to be port forward, which that would be telling your consumer router to do destination NAT and make an allow firewall rule through. So, yeah. In the end, though, they're just vendor terms that you have going on. Which is why I like the Palo Alto flavor of NAT as an extra special treat. So, why port 8080 here?
Because that's the one you're supposed to hit from the outside to get to the internal.
That's support from the outside. Yep, going to the internal server. We need to add another pool, which I go server 2 on port 80. 251, right?
Yeah.
What inside port do we want to access then? 80, because it's a what kind of server?
HTTP.
It's a web server, yeah, it's HTTP. So we'll go, oh, see, I'm already losing my consistency between the two things. So either way, we'll hit OK on that. At this point, could we go test this? Again, make sure that the NAT worked. Yeah. If we go over to the monitor tab, go to NAT, and destination NAT, we should see two rules in here now. So when we flip over here, pro tip with Internet Explorer though, you need to make sure it has HTTP in front of it. Now, we still know it's going to fail, right? Why is it going to fail? No firewall rule to allow the traffic. So when we look at this, there we go. We got 3 translation hits again. So that must be IE tries 3 times and hangs it up, right? That must be what we figured out there. Where to next? So we have NAT done. Now we actually need to make firewall rules, or the security policies. So under our security policies, I saw a lot of you flip to all. That's cool. When you do all, you cannot change the order or evaluate the order of rules, because you're looking at rules for different zones, and the order of rules for different zones doesn't matter. So, anywho, WAN to DMZ, we need to add a rule for this, right? Why is it WAN to DMZ? Let's do that first. Yeah. We have traffic coming from the internet. How does our firewall now know that the traffic will be going to the DMZ network? Because NAT did that for us, yeah. Before the packet arrived over to the security policy processing, NAT said, boom, here's this IP address that you're going to. Then this being a router realized, oh, that happens to be over in the DMZ zone. So now we go add. What should we do first? Should we just do the port 81? Allow internet server 1. We will permit this from zone. It'd be nice if this was contextual. Like if you were looking at internet to DMZ, it would pre-fill out the form for you. But it's not. Okay, so we've got allowing from there to there. What is our source going to be?
Everything but dog.
Everything but dog. So initially, to allow the internet in, we want to let everyone in, right? And we'll come back to the but dog in a second, because isn't that the rule? Allow everyone but the... But do not allow any machine on the dog, but allow anyone on the internet. So we're just going to block this one group. So we first thing I'm doing is allowing anyone from the internet. What's the destination address going to be? So it's going to be server 1. So is it going to be 24.220 blah blah blah, or is it going to be 192.168? 192.168. Why? Because NAT changed the address to be that. So that's server 1 in there. What's the protocol? HTTP. Ooh, there we go. We'll hit OK. Now the rule said don't allow the dog network in. So how would we do that? We need to make a deny rule.
Why would we not have done in source address exclude matched addresses and thrown in the dog network? Because then that would permit everything but dog, would it not?
It would have.
Okay, because that's what I did.
Yeah, that works. I've
always been told,
as a rule of thumb, try to avoid exclusion addresses and would rather have two separate policies. And the reasons for that would be, generally your logging and stuff you do is based off of individual firewall rules. So if you made a rule that excluded just the dog network, basically the idea is you want your logs to be able to see people coming in and successfully accessing stuff. And if you're specifically blocking something, you might be curious as to why. So you'd want a separate rule showing, hey, they're trying to get to this and we blocked them, kind of thing. The other one is the people side of it. When you start mixing exclusion rules in there, eventually when you get enough rules, you'll get confused. Or something in your mind will flip upside down and then you'll be confused. That's a couple reasons why anyway. That being said, it would totally work. So deny dog server 1. Our action will deny it from WAN going to DMZ. What's our source going to be? Yeah, so 64. If you put 24220, that 24220 address on the dog network is used for one purpose only. What's that? It starts with an R. Routing. That's all it's used for. Since dog does not use NAT, then we don't actually worry about the IP address. Same with like when you guys are out on the internet here at DSU, you really can't figure out what our edge router's IP address is. Unless we do trace route and enable on it, which maybe we do, maybe we don't, I don't know. So same situation going on there. Whereas like at home, you can go, what is my IP address.com, or actually my favorite way of finding, you can Google it, or IP chicken. If you want to find out your WAN address. Now, is this DSU's router address? No, that's my laptop's address. But either way. And my only reason for IP chicken is of all of the like quick grab my IP address type of websites out there, I've never forgotten this one because it's IP chicken. So anyway, we're going to deny this going to server 1. And what are we going to do for an application?
I think this is where
This one could go either way. Since this is an explicit deny rule, we could put two things.
you could do HTTP.
We could do HTTP, yep. Because all that's been allowed into this is HTTP. Or, since dog's not accessing anything else on server 1 anyway, we can just do any. Are they both going to be functionally equivalent? Yeah, they're going to do the same thing. There we go. And if we look, it was even nice enough to put them in the correct order for us, which was cool. One other thing that maybe if I go back in to edit this, for troubleshooting on any firewall, is turn on the logging for your rules. That will make an amazing amount of difference. Yep, it sure is. Because I just said it was in the correct order, and it's not.
Okay.
Yep. So we need to move that up. There we go. That is now in the correct order. Because we want to block the dog network, because we want this. This is our, of these two rules, the block or the allow, which one is more specific? Well, our block rule is more specific. Yeah. So that's, if nothing else, for your general rule, that's what the way we ordered is our most specific one first, down to our least specific. That's a general rule, though. General rule for how to make your rules. Yup. And there we go. The purple jumping goat. So we got that one done. What's the other rule we need to now create?
One for accessing port 8080.
The one for accessing port 8080. So for troubleshooting's sake, well, let's do this. Allow, this should be dog server 2, right? That we're making. So the zone is going to be WAN going to DMZ. And what's the source address going to be? The dog network. Then, so I'll do that here for now. And what's the destination going to be? Server 2. Server 2. 192.168.253.151. 251. That's actually that's a Kyle quirk. I always miss this, and I go hit OK, and it's like you need to pick a policy action. And I just start hitting tab, and I just zoom through this when I use the GUI and miss it like every time. So Thanks for the heads up.
You gotta add the address.
So we need to add our address. And what's the application going to be? Do we need to go create something for port 8080 now?
I believe so, yes. Because EXT hooked up was like 7001.
Well, natting's already done from 8080 to 80.
Yeah.
I just realized,
Nat
I'm like, are you
has
kidding me?
already translated the packet. The destination port of the packet is now 80. So the rule is just for port 80. Now, for the sake of testing, there's one change I would make first, and then we can go back and modify it. What's that? If we go to test this, we're now dependent on this firewall being correctly configured. What should we do for fun first? Let's see if we can get to it from the internet machine first. If we can get to it from the internet machine, that's going to tell us one of two things when we go to troubleshoot later. Either the dog firewall is incorrect, or you type the fixed route in wrong. So we zoom back over here, tack on an 8080, and we got a yellow goat. So we know that works, so we can come back in here now and switch this rule back around and not be Annie and allow the dog network, like so. Scroll bars for days. Let's full screen this. There we go. Is there anything else we need to do for the whole rest of the, or for this section? Is there anything else we need to do?
But it's not on Go.
What's that?
Not on Go. I mean, dog out.
We need to configure, yeah, so we either need to have dog out to get our screenshots here, but I'm just thinking from the holistic process of like, I can log out of the Juniper firewall and never touch it again
No.
for the whole rest of the lab.
You need a NAT source.
We need to NAT our outbound traffic. Yeah. If you were looking in your Palo Alto logs and you would see traffic coming back to you from a 192 address, that means that this isn't doing its NAT. Because should you ever see 192 on the internet? No. That's why a lot of firewalls will have a, like pfSense, just by default on the WAN interface, blocks all the private addresses, which when you go to use it internally for stuff might confuse folks sometimes. So you have to go and check that. So we need to do source NAT. Why is it source NAT? What time is it? 10:12.
You know the address coming in.
Yeah, we know the address where the traffic is now coming from when we're doing source NAT. It's coming from zone untrust, going out to WAN. So, like so. So, what's our rule going to look like? Oops, that's not. There we go. What's our source addresses? What are they going to look like?
It's going to be the private address.
So,
2.1.
like so. So we put it in the subnet. Technically, since we're using the zones, you could also put 0000 in there, but either way. Do we know the ports that stuff will be coming from?
Not really.
No, because what port range would be inside of here? Starts with an E. Kind of egress. We could get away with calling them egress ports. If that was an essay question on a test and I was like, what are the outbound ports called? And you said egress, I'd be like, well, you're close. But it does start with an E. Ephemeral, yeah. That's where the ephemeral ports go. And so we really can't predict those. We could specify that only TCP traffic is going to be natted or something silly like that, or we could just leave this blank. Do we know the destination of where folks are going to be going on the internet? No. So what's our action going to be?
Source is egress.
Do source NAT with egress interface. Address. We hit OK. There's the rule hanging out right there. We hit OK again. Anything else we need to do on this firewall before we're done? There is a commit. There's one other thing we need to do before we commit.
I assume the last source NAT out.
Yeah, we actually have to go make a policy allowing the LAN to go out to the internet. So if we look at untrust going to WAN, there are no rules in there right now. So we got a policy, allow untrust going out to the WAN. We're going to permit it. Untrust going to WAN. We could enter in the untrust or the LAN subnet, or just say any. Doesn't really matter here. I usually actually will explicitly put the subnet in there, but really that would just block someone that has somehow put a router inside of your LAN, which may or may not be a problem. In the case of the iLab, I do that because you could bypass firewall rules if you got routing to work. Difference being I wouldn't accept your routes you're publishing out, but either way, we're just going to allow an any. Now we need to commit. Is there anything else we need to do on this firewall? Nothing that comes to mind. How about that? So we should be okay there. We open up Goat. I should have pre-logged into this to allow, oops, not Goat, dog. Dog, admin, there we are. Should have pre-logged into this and let the little interface warm up, but I didn't. So, we'll get in here. We notice everything on the dog network is using public IP addresses. Why is that?
Because you were nice and didn't want to force us to do NAT.
Yep, I didn't want you to make you have to do NAT on Palo Alto because it's an interesting process. How about that? We're doing like for CCDC. There's all sorts of crazy NAT stuff that goes on with that because we're like simulating the internet using private network space and stuff like that, and giving all these businesses their own network, and they have a Palo Alto firewall, which none of this is proprietary. I emailed out the teams and told them, even give them access to the Palo Alto training. So anyway, did all of that, but I wanted to pre-configure the NAT for them because it's silly. So they had static blocks of addresses in the middle of a subnet, and that probably took me an hour to figure out because there was a subnet mask configured wrong somewhere in deep within. So it's interesting doing that on a Palo Alto. So we come over here and we look at our interfaces. What does Palo do that's weird with their numbering compared to everything else in the world? Yeah, their interfaces start with 1, which is cool, I guess, instead of 0. Either way, it is what it is. Let's look up here. Interface 1 is connected to something and should be in the 6443 250 subnet. So we change the interface type to layer 3. Don't have a NetFlow profile. This is one that we had some whoopses on. We have to give it a virtual router. Juniper is doing that in the background for us. You can go make virtual routers in there. What does the virtual router do for us?
Create a virtual router.
It's attaching a routing table to the interface. So, like I said, the Juniper one is a large truck driving back there right now. Wonder if we're getting another pod. Anyway, there's not very often you see a truck that's like level or above the window out there backing through the thing. You know the storage pods up front?
The new one.
I thought you were.
Anywho,
For the bad
somehow the firewall needs to know this subnet on this interface and this subnet on that interface. Routable, right? We don't need to go out somewhere else. That's the purpose of the virtual router. If you had like multiple, if you wanted to keep routing tables separate, that's where you'd make multiple virtual routers, or one of the reasons why you could. For this first interface, the Palo does not come with zones, so we need to make a new zone. What was interface 1 connected to?
You want the IP address?
No, I was just philosophically, what is the network? It's the LAN, so what should we call the zone?
LAN.
We call it LAN. Sounds good. Does the name really, from a functionality standpoint, matter?
Yeah. So he's going to look at it and it's labeled ASDF. You're not going to.
Yes.
I call that a functional. How long?
Good point. Yes, if it's a silly name that's really a challenge to...
You have a dot.
I do have a dot after that, don't I? There we go. Yes. If the name is so silly that functionally you can't make it work, that's gonna be a whoops. So interface 2, we'll go and set this to be a layer 3. Virtual router would be default again. What was interface 2 connected to? That was connected to the internet. Or we could be fancy and use trust, non-trust, whatever, doesn't matter. So 24.220, 181.102. As a small little aside, most of the folks that needed, or that I helped out with stuff or emailed in for help or whatever, is usually just a typo in an IP address. I would say like 90% of the questions I answered was just a typo in an IP address. But generally speaking, I wouldn't be super helpful about that. I'd be like, you need to check your IP addresses. And go along with that. But, yeah. So double, triple, quadruple check that your IP addresses you're typing in are correct. Oh, I have no idea what this next one was. So now I'm on to DMZ 64.43.242. 64.43.242.1. There we go. In the interest of saving time, I'm not going to commit this yet. I'm just going to try to make all the rules first, because it's going to take 3 hours to commit. So the interfaces are configured. What do we need to do with dog now? Dog's rules. Allow the internet to access the website on server 1. So we will add a new policy. Allow internet server 1, right? What's the source of the traffic going to be? Source zone? WAN, so it's coming from the internet. Do we know the source address? No, because it's coming from the internet. Do we know the user that's authenticated? No. Where is it going to? So it's going to the DMZ, and the address for server 1 is 64.43.242.247. I would probably went and made an object that was just server 1 just to keep things sane, but in the interest of keeping this going. Under applications in Palo, what are the applications? We see a list of very odd looking things in here. what does this firewall do when it's talking about an application? What type of inspection on a packet? Yeah, it's not, is it looking at ports when we're here? No. So this we safely left as any, or you could actually tag it with web browsing, like so, if you wanted. But for everything we'd been doing thus far, just left that at any. And what service would we be on? Services are where the Palo calls ports. So we'd say allow that in on HTTP. Oh, I should make sure the action was actually allow, which I think it is by default. And there's one other thing I should make sure of, that yes, we are logging stuff. Okay. So we got that. So there's that rule. What's rule number 2? Only allow the GOAT network to access the website hosted on dogs server 2. So our second rule would be, if we only want to allow GOAT, allow GOAT server 2. What's our source going to be? Source zone again will be WAN. What's the source address going to be now? (24.220.181.101). Why is it not 192.168? Yeah, if it ever was 192.168, that would mean natting hadn't happened. Will that work if we try to do 192.168 stuff? No. I mean, the SYN packet will get to the server. 100% will succeed. When the server goes to reply, it's going to hand it back to our router, or our virtual router inside of the Palo. What's the Palo going to say when it gets a packet destined to 192.168? I don't have the slightest idea how to get there, and it's going to drop the packet. So, since this network was using NAT, that's the IP address. The destination is DMZ on 6443 242.123. 242.123. And we'll just skip over to service and allow it. So another quirk of this, why it separates these out, and you notice the default on this is always application default. So if we went over here and said web browsing for an application, what the Palo is going to do is, gee, if you're browsing a website, there are some default assumptions we can make, right? If we've analyzed your traffic to the point that we figured out this is web browser traffic here, we can probably assume what port? 80. The problem is we can also assume maybe some other ports depending on the application too, right? Is 8080 a web browsing port? Yeah, it's pretty common actually. I mean, pretty common among present company, right? Mom's not doing a lot of 8080 in her day. But that's what's going on there when we pick application default, is it's like, yeah, this is probably the port. It's making assumptions for you. Is there anything else we need to do on the dog network? We need to make an outbound rule to allow the dog to get to GOAT, allow LAN to the internet. So here our source will be the LAN network. Our destination will be the WAN. Here we want to pick any instead of application default, because if we don't have an application picked. So we come over there and go to actions, make sure it's allow, and we'll log it just so we see what's going on. That should get us pretty close. We'll see how we do. We're going to commit this. Just going to take a second. Yeah, it's actually not taking too much. That actually went surprisingly fast. So, in theory, should this work? We try to just go to 101. Next, we put a rule in to block it. Port 8080 worked. We got there. The pro tip for when we start to have troubles is go to the monitor tab. As slow and clunky as this interface is, it has really good logging and monitoring that it does. So when we look in here, we see the traffic we sent out on port 80, applications incomplete. And the reason the session expired was aged out. When you think about from the concept of just TCP, reason for session ending, if a session aged out, what does that mean?
Somebody probably dropped the packet.
Yeah, like the session didn't like close down or something like that. Let me if I manually refresh this, see if we get something. Versus here on the 8081, you know, we'll come back to application. The reason the session ended was TCP fin. What does that mean? Yeah, we nicely said our goodbyes, right? If we see a TCP reset, what's that mean? We got a big middle finger from someone. Yeah. That means that there's a firewall that's not dropping packets, but it's rejecting them. Which is another way to see, like, is this problem at this firewall or that firewall if we send resets back? Another, just kind of, then from the application standpoint, the PAL is like, hey, that traffic is web browsing. So if it's able to figure out that much, why over here is the packet labeled incomplete? Even if we can do really, really awesome deep packet inspection, if we know that the Juniper firewall was blocking this packet, what did we send to get this here? Did we even get that far? Because what's happening to the firewall? What's the Juniper firewall doing on port 80 from the dog network? It's doing what to the traffic? It's denying it, which means when it receives, before it gets a GET request, what's it going to get first? It's going to get a SYN. What's it do to that SYN? Drop it. No one can figure out what the hell you're trying to do with just a SYN packet. And that's why this is labeled as incomplete. So when we look in here, we see it aged out, essentially meaning we sent a SYN and no one returned our call. So from a layer 7 standpoint, we're like, you know, trying to be elite, and we're going to figure out what this is. All we got's a SYN. Do we know what's really there? Not a clue. So what are our other hints? Oh, here's the other one. Bytes received. We know we sent 132 bytes. It's a hearty amount of SYN, right? Looks like we must have sent it twice. How many packets did we get back, or bytes did we receive back? 0. Our call is not being returned. So that's how we can check on that. So the monitoring is pretty sweet. I suppose the last thing we need to check then is, can the goat get over to the dog now? What should be 64, 43, 252 dot 247 and 123. No. Yes. 247.
Yeah, 242, 247.
242. Oh, yeah, that's super not going to work. So there's that one. That one worked. And the other one was 123. Which, should that one work? No. Because we made a rule it's doing what? Yeah, it's blocking it. So if we refresh our logs, we see the dog network came in and we allowed it. Interesting enough, I don't see our traffic getting blocked in there. Maybe I didn't turn the logging on for the full session with that. Oh, no, we don't even have an allow rule for it. So this firewall, if we don't have a block rule, what does it do as far as logging is concerned? Nothing, yeah. So the traffic that we just never allowed in, we're not going to log it or say anything about it because we didn't make a rule for it. If we wanted to see the blocked traffic inside of the log, we would have to go down here and make a deny all rule in there. So, any other questions? Nothing? Okay. So with that, we will put a fork in Lab 4.